What type of spray equipment is required to apply the ETT onto concrete? We can be applied by backpack sprayer, motorized sprayer, spray rigs. Preferably the application is done by backpack sprayers to read different absorption rates in concrete. Concrete is not a uniform substrate. Certain parts of concrete absorbs a lot of water, certain areas are not. Since we are water-based and we work by capillary pull, wherever you have a more water absorption and more capillary pull, you need more material to be applied to have deeper penetration. And therefore, backpack sprayers, spray rigs, anything that gives a uniform, controlled application of spraying onto the surface is the only equipment you need. How do I know if a sufficient material has been used during application? Is the mapping of the surface of the area. So we have 200 square foot a gallon, 5 meters square liter. So you're mapping how much material by square footage or square meters you need for the surface area and make sure that you use that amount of material for the concrete. Given that you have to make sure that the application is not puddling on the surface. Concrete is not a uniform substrate. Areas where the concrete absorbs way more material, you need to bring more material into it. Concrete which absorbs less, you can move on. The key is do not puddle material on the surface. Do not overuse material on the surface. And don't use too little of the material on the surface. By the average of 200 square foot a gallon and 5 meters square liter, you will be all right. But concrete is different. Every single concrete surface is different. Every concrete strength is different. Every absorption is different. The golden rule is that you spray as long until you get saturation of the concrete. How do I know I get saturation? I spray enough material until the color changes and the material ATT just started to sit on top, and then I move on. That's the golden rule. But for calculation and for specification basis, you follow 200 square foot a gallon, 5 meters square liter. Is it important to do all the watering in a timely manner? In our ETT, it is very important to get the watering right. The watering is the most important part in the process to install any kind of our ETT products properly. The first watering happened in the same rate that you apply the material. 5 meters square liter, 200 square foot a gallon. The watering is the same rate. 5 meters square liter, 200 square foot a gallon. The sweet spot is between 1 to 3 hours. Less than 1 hour, you didn't have the material to have enough capillary pull. More than 3 hours, and it's just too dry for the enzymes. The enzymes needs a lot of moisture and water to free the calciums out, to create and jumpstart the reaction between the enzymes and the calcium. So if it's very hot, you're going towards 1 hour for the first watering. If it's a little bit less hot and you have damp surfaces, more moisture in the air, more surroundings, then you go towards 3 hours. You never go above 3 and you never drop below 1. What happens if it rains during the application of ETT waterproofing? If it rains below 1 hour, you need to reapply. If it rains above 1 hour, great, because you don't need to re-water. Back to the watering. Less is more. No flooding, washing, major drama on the surface. You apply the watering the same rate you apply the material, especially for the first one. Capillary pull, water goes on top, capillary pull. You don't want to wash with high pressure washing, doing watering, material out of the cracks, out of the fissures, out of the opening. The idea is that the ETT gets absorbed inside the physical matrix of the capillary pull by the concrete. Water sits on top, it puts it out further, washes out the calcium, the free calcium, which reacts with the enzymes and build the gel that makes the membrane to waterproof your concrete. Most important part is if you have rainstorms coming after that, after the watering, we are totally fine. So again, golden rule, rainstorm below 1 hour, you need to apply the area. Rainstorm after 3 hours, after you completed your watering, no problem at all. Light rain that goes to instead of your watering is fine as well. A thunderstorm where you cannot see the other side of the road, well, maybe it is, and it comes too early, it's too much water. Right? If it has been raining, how do I know the concrete is dry enough to treat? The concrete absorbs water, we get absorbed. The concrete doesn't absorb water, we are not getting absorbed. If water sits on the top, it's too saturated. Concrete saturates. That's why we have puddles. If concrete is too wet and it saturates, we are not getting in. So the simple golden rule, or the thumb rule of it is very straightforward. A water test. Water bottle on the surface, water puddles, we will not get in. Water get absorbed, we get absorbed. Touch dryness, touching it, if the hands gets wet, I have water on my fingers, it's definitely still saturated. It's a general rule for this. Please reach out to the technical department, more definitions for this, but in principle really is, as long as the surface is touch dry, the surface absorbs water, we get absorbed. What happens if the ETT is not watered into specification? Oh, that's very straightforward, you have to reapply. If you don't put water in between 1 to 3 hours, you need to reapply. How soon can ETT be applied on newly poured concrete? I prefer 30 days. The minimum is 14. Concrete basically is hydrating. Moisture goes out of the concrete. We want to get in. Why 30 days is because generally the engineers will allow you to they make a crash test, 7, 14, 21, 28 days. That's your performance of strength in the concrete that will be tested. Most construction sites where the engineers doesn't allow you to do anything to a concrete as it don't officially had final 28-day strength development to be released down to the waterproofer to do the waterproofing. Also the most amount of shrinkage happened for the first 30 days on the concrete. Shrinkage cracks that happen that I see, it's easier to seal than new forming cracks that is built afterwards. So if you have to, the minimum is 14, I prefer 30. What is the best way for newly poured concrete to be cured prior to ETT application? Curing compounds in concrete generally disappear very quickly. If it's polymer based, you most probably just need to water jet the surface. We need to get rid of the oil with emulsifying cleaners. But generally, we apply the ETT technology after 30 days old concrete. If it's 30 days old concrete, most of the curing compounds and foam release oil agents of formwork has been by that time dissipated or disappeared or washed away or weathered away. If there's still residue with them, just generally water jetting and cleaning the surface will do. Can ETT agents be applied on projects where other waterproofing sealer materials have been used previously? Well, if the sealers have been approved recently and the sealers is still present on the surface, you need to be able to most likely blast them away. If they're older and they be removed with water jetting, it depends entirely what kind of sealers we're dealing with. There are so many different technologies in the sealer world. If the sealer is pore blocking, beading and shining on the surface still present, it needs to be removed by blasting mechanically or water jetting or grinding or scarifying or any other way. If we don't get into the concrete, then ETT does not work. The simple test for that is, again, water on the surface. If water beads, we're not getting in, you need to surface prep. If the sealers are very old, most of them are worn and torn already after a couple of months and they disappears on the surfaces, golden rule is, water get absorbed, we get absorbed. It shines and beads on the surface, we are probably not getting absorbed. Is the ETT compatible with other waterproofing products during the installation of expansion joint or the detailing of penetration, etc.? In Alchemco, we are providing a full system of products in the entirety to the waterproofing problem and therefore its solutions. You can get an entire product program from us, from the expansion joint to the treatments, to the upturns, to the change of planes, to the water treatment floor traps facilities. So whatever the details in the system, ETT technology comes in-house in Alchemco with the full problem solution system, which it tackles any kind of details and terminations and necessary on your construction project. Down from an expansion joint to a water stop, to a floor treatment, to anything else in that concrete. What shelf life does the ETT have? We have no shelf life. If ETT becomes frozen in a container, does this destroy the performance ability of the product? The ETT has to be watched for two items that is important on construction sites. First, the cooking of the water with the enzymes inside the plastic drums under direct sunlight exposed onto the concrete deck. So it's sometimes that the contractors for work on Monday morning put on Friday afternoon the plastic drums closed, sealed, under direct sunlight in the middle of 110 degrees, and it gets so hot that you basically cook the enzymes inside the plastic drum. If the enzymes are cooked, the likelihood that it's been destroyed is very high. The same is for freezing. Protect it from freezing like any other waterproofing product that is water-based. We are no different. If you cook it, this is not about the surface and ambient temperature. It's the idea when you drive in the car and you touch your plastic on the dashboard, on your steering wheels, and it's so hot that you can barely touch it. You can actually literally cook water inside the confined plastic drum. Then you destroy the enzymes. To be sure, is it working and non-working is very easy. You open the drum, you use the ETT, take it out, and make our accelerator in the combination in the pail, mix it together. If it gels in the pail, the enzymes are alive. If nothing happens, you killed them. But as a good golden rule for storage and handling of the product, common sense prevail to water-based product in terms of freezing. Do not freeze them. Second, for heat, no problem with ambient temperature. It's so for transport on flat bag, trucks, or internationally on pickups or whatever you call them, the issue is plastic sheets helps. What I used to do, 2 pallets, one right, tarpaulin or plastic sheet over, protected from direct sunlight, and you're fine. Inside construction sites, 1 floor below. Make sure you're in a storage area, in containers, somewhere where you get it away from direct sunlight. That is basically only there for not being able to overdo in summer and hot months the cooking of the enzymes inside the plastic drum when the plastic drum is sealed. If it's open, the temperature doesn't matter during the application. The ambient temperature is not a concern. Freezing on cooking is a concern. In addition to this, once the gel has formed inside the concrete matrix, temperature is irrelevant. I've done many cold rooms where you can have -20, -30, and you can have the enzymes in the concrete can withstand 400 degrees Fahrenheit, 200 degrees Celsius, because hot asphalt can be applied on top of it without melting the membranes that is formed inside the matrix of the concrete. What I'm referring to is the actual raw material in itself before the gel is formed of the enzymes and the calcium in the concrete. Then you're irrelevant what the temperature does. The concrete will fail first before the enzymes fail. So if the concrete melts away because of heat, we will fail, not because of us. We don't fail first before the concrete fails. The concrete fails first before we fail. Second one is the surface temperature is a very important part during application. So if you are having, if I have this where people ask me the question, I have 50 degrees on the surface for 1 hour, but at nighttime I have -20 degrees and the concrete is inside so frozen and so cold that even if the surface is still a little bit warm, it does not help us. Capillary pull and capillary absorption is where we work. When the concrete is completely solid, cold, of like -20 degrees Celsius or 0 Fahrenheit, you will not have capillary pull because the water, which is the carrier, freezes in the member of the concrete. So make sure the whole system, the whole concrete is above freezing at all given time. For the high temperature part, if the surface temperature reaches 100 and above and it gets too hot, the easiest solution to the problem is spray water. Don't just wait for the water to evaporate, apply ETT, 1 hour later water, and once the gel is formed, you're fine. You may want in very high temperature and very dry areas to contemplate the idea that you spray water the next day and more water, more moisture and more water into the concrete on the second day helps you with the gel forming.